So you're here to hear about Windows Azure Media Services. And in a nutshell, this is a managed solution, managed cloud scale solution for managing, encoding your video content on Windows Azure and streaming that content through Windows Azure to a variety of client devices. And we'll see exactly how uploading and managing your content works. We'll see what encoding means and which devices you'll be able to use once you encode your content. But first, let's take a look at a couple of scenarios which people have been using Windows Azure Media Services for. So one case study that I have is a customer with several hundred employees worldwide. And they have a bunch of training videos that they want to share, make accessible to all their employees. Now, they obviously don't want to put them up on YouTube and make them accessible to everyone. They also need some kind of access control, and they want to stream these videos to any device the employees might have. So the employees might be watching these videos on site, and they might be using their iPhone while commuting to watch these training videos. So this is one scenario in which Windows Azure Media Services gives you a hosted, managed solution for uploading, encoding, and delivering your training videos. Another example at a slightly larger scale is the London Olympic Games back in 2012. And Microsoft has partnered with the Olympic Games to deliver the content, deliver the games, streaming and live and recorded sessions to several 100 million viewers at peak. And this was done using Windows Azure Media Services. And again, there's extreme scale problems here because you might have only a couple of million viewers for a particular slightly more boring sports event, or you could have hundreds of millions viewers for the opening ceremony or the closing ceremony of the Olympic Games. And another scenario is more generic. You might be an ad agency, you might be a cellular carrier, and you have videos that you want to share or publish to your customers. You might be a consumer video website, and you don't want to worry about setting up one of these data centers. You want to use the cloud scale offered by Windows Azure to host, encode, and deliver your content. And so this is what Windows Azure Media Services delivers. So let's review some of the features before we get into the actual demos and code. So the first thing that Azure Media Services was able to do since the very beginning, and the very beginning is just about a year and a half ago. It's a pretty new service comparatively. The first feature is VOD, video on demand, viewing on demand. This has been available since day one. So basically you upload existing video content and then you can deliver that to your customers on demand. Live streaming, where you broadcast live content, was used during the London Olympic Games, but it's not yet publicly available. There's a bunch of customers in a private TAP program, kind of a beta, pre-beta program, but there's no solution publicly available that I can share with you and show you today. And this is coming soon, like really soon. They said Q3, now they're saying Q4 of this year, so I really hope it's going to be available soon. And you'll see how you can also upload and deliver live content through Windows Azure. Another nice feature is encoding to multiple formats. So you don't have to commit upfront exactly to which formats you're going to be delivering to your clients. And in fact, there's no single format which would be suitable to every kind of client device. So Windows Azure can take your input files, say an MP4 file, and then encode that to a bunch of different streaming formats and even different bit rates to make that available to your customers on various devices and various bandwidth specifications. Another related feature is encryption, DRM. Windows Azure Media Services offers DRM support. You could encrypt the content, or you could add the additional DRM layer with Play Ready, which is an existing solution that's been used on Xbox and other devices. And now, in terms of delivery, you have basically two options. One, which we call here progressive download, and the other, which is smooth streaming. So basically, progressive download is where the browser or the client device just downloads the video file progressively and then plays whatever it's got available. So there's no good support for seeking. There's buffering involved. So if the bandwidth isn't sufficient, you're going to see lag and buffering and hiccups. Smooth streaming, on the other hand, is a streaming solution which supports seek, so you could seek arbitrarily to any position in the media, and also variable bitrate. So if at some point you're using a second generation cellular network and then you switch over to powerful fast Wi-Fi and then you switch back to 3G or maybe 4G, the same stream is going to adapt to your bandwidth connectivity specifications, and there's not going to be any buffering involved. You're just going to see a slightly lower bitrate or a slightly higher bitrate as you move from one connection to another. Another feature is dynamic packaging. And dynamic packaging basically means that you don't have to encode your content to all the different formats up front. You can tell Windows Azure Media Services, here's my MP4 file, and here's a bunch of URLs that I'm going to be accessing that content through. And then when you hit one of these URLs, Windows Azure Media Services is going to encode the original content to the appropriate streaming format, for instance. So you don't have to encode up front, and you don't have to pay the encoding costs up front and the storage costs up front. Whenever the content is accessed, it's being encoded for delivery. In terms of client SDKs, how you access Windows Azure Media Services, there's a first-class SDK for .NET and Java. This is kind of weird, but there is a Java SDK, a first-class Java SDK that's been released together with the .NET SDK. Both of these SDKs are evolving. They have features for upload, for managing your assets, for encoding, for delivering, for streaming, for securing access to your content. It's all available through a bunch of APIs. And it's also available through a REST API, through HTTP endpoints. So if you want to use Windows Azure Media Services from Python, you can go ahead and do that. Just hit HTTP endpoints with a specific token, and you can upload, encode, deliver your content. So that's kind of the features at a glance. Now, in terms of, yeah?
The difference between the progressive download and the streaming, why would you use, or what scenarios would you use progressive download?
Okay, so the question is, what's the difference, or in which scenarios you'd use progressive download at all if smooth streaming is such a superior concept? So not every device, not every version of every browser, for example, supports smooth streaming at all. So we're going to see exactly the device support matrix. And for example, on Android 2, there is no good out-of-the-box solution for smooth streaming support. So you do have to fall back to just downloading the, let's say, MP4 file and playing it progressively. The same applies to older feature phones, Java ME phones. So if you really want to target the widest possible audience, you'll also want to provide progressive download. Also, inside your organization, on a local area network, for example, if you have super fast internet access, you might just not want the hassle of encoding to smooth streaming if you just know that whenever you hit the MP4 file, you're going to download it much faster than you can possibly play it back. On the other hand, if you use progressive download, it means the clients can actually download the MP4 file and put it on a USB stick and take it home. Whereas with progressive, with the smooth streaming, you usually it's usually harder to capture the content. So that's another trade-off here.
Can I ask a question? Is that smooth streaming the Silverlight smooth
Yeah, that's Silverlight smooth streaming and HLS, which is Apple's HTTP live streaming. I'm going to talk about that in just a second. Okay, very well. So we set the stage. Now let's talk about the formats. So currently, the import formats that Windows Azure Media Services supports is a subset of what IaaS Media Services supports, because Windows Azure Media Services, at the end, is built on top of existing Microsoft solutions for media streaming, encoding, and delivery. And so there's a bunch of codecs and file formats supported. It's more than just plain MP4 or WMV files, but still it's not as rich as what you get from IaaS Media Services hosted on premises, at least at this point in time. Now, of course, you could always encode your existing content to one of these supported formats, like MP4, and then upload it to Windows Azure Media Services, but there's definitely room for more formats being supported in the future. But still, you see the common ones here: AVI, MP4, MPEG, WMV, 3GP. These are the popular formats and the popular codecs that are supported. Now, in terms of export, which is what Windows Azure Media Services can encode to, this list is much more limited. So you basically have 3 options here: WMV, MP4, and the smooth streaming file format. And you can take one input asset and encode it to multiple output formats. You could also take multiple input assets and encode them to the same output format. There's some control currently, but not full control, over how exactly the encoding process operates. So there are some interesting things that you can do, which I'll show you in the demo, but it's still, at this point in time, not as powerful as what you'd get in an on-premise solution. On the other hand, it's hosted, and you don't have to set up IaaS media services at all. And if these input and output formats are good for you, then you can just go ahead and use Windows Azure Media Services right away. If not, you might have to pre-encode your media files before uploading them to Windows Azure Media Services. Now, in terms of the supported devices, I have here a list of how you would play the smooth streaming formats on a variety of platforms. Because progressive download, where you just get an MP4 file to the browser or to the client app, is basically supported by everything. If the codec and the MP4 file format is supported in general, you're going to be able to download the file to the client and play it back. Smooth streaming, on the other hand, requires some more SDK and platform support. So we have 2 smooth streaming options, two smooth streaming formats in Azure Media Services, and that's IaaS smooth streaming, which is also known as Silverlight smooth streaming, and the Apple HTTP live streaming, which is also known as HLS. And you can take a single MP4 file and encode it to both smooth streaming formats, and that's exactly what we're going to do in the demo application I'll show you. So you can take a single MP4 file and encode it to these 2 formats, which then makes it accessible to all of these platforms, basically. So for instance, on Windows, in Internet Explorer or Chrome, you can play back IaaS smooth streaming with the Silverlight plugin. Now, Silverlight is kind of going away, but it is still supported. It's still part of Internet Explorer. You can still install Silverlight for Firefox, for Chrome on Windows, and so you can play back IaaS smooth streaming through the Silverlight plugin. You can also play back the HTTP live streaming format on Windows, but that requires a third-party SDK. There's a bunch of them, like JW Player, for example. They're usually Flash-based. And again, Flash is kind of going away, but you still have it on most browsers, enabled by default or available for easy download. So that's how you make these 2 streaming formats accessible to Windows clients. Another example would be OS X. So suppose you want to access, suppose I want to access my media assets from this Mac using Safari. So again, Silverlight is actually supported on Mac. That was kind of the selling point for Silverlight. And so you can use Silverlight in Safari or even in Chrome on OS X and then play back your smooth streaming content. Safari also has built-in support for Apple HTTP live streaming, which kind of makes sense. So inside Safari, you can play back this kind of smooth streaming format using simply an HTML video element. You just point it to the smooth stream URL, and it will play back the content for you. No plugins, no third-party SDKs involved. So, you know, there's a bunch of different platforms here, so let me just review a couple more examples. So one interesting example would be Windows Phone. On Windows Phone, there is an official Microsoft SDK for playing smooth streaming URLs. It's not sort of in the box, but it's easily available and it's supported by Microsoft. So you can have a Windows Phone application playing back content from Windows Azure Media Services through IaaS smooth streaming. Another example would be an iOS application. So again, an iOS application has native built-in support for Apple smooth streaming. So again, you can just simply use a part of the iOS SDK to play your media from Windows Azure Media Services. So essentially, if you encode to both of these smooth streaming formats, you make your media accessible to virtually every important platform: desktop browsers and mobile browsers plus mobile applications. There are some missing cells in this table, but there is at least one solution for each platform, as you can see. Even for Xbox, there is a Microsoft SDK for playing IaaS smooth streaming media. So now that we have this support matrix, let's just take a look at the pricing and then at the Windows Azure Media Services portal, which is where you upload your assets, encode them, view the status of your encoding jobs, and publish your media. So the pricing principles are as follows. And again, the prices here are just the publicly quoted prices. If you have an enterprise agreement with Microsoft, you might get much better prices than this, but that's as high as it gets. So you pay for data processing, which is encoding and packaging your media. If you just have MP4 files that you want to store in Azure Media Services and make them accessible as MP4 files through progressive download, you don't have to pay for this component. But if you want to encode to the smooth streaming formats, this is what you pay. So you pay $2 or $1.50 for gigabyte for the encoding and packaging of your content. And then you pay for storage, which is standard Windows Azure storage costs. This is super cheap and geo-replicated to at least 2 data centers. You pay for bandwidth, so whenever your clients access the content, you pay for the outgoing bandwidth. This is also the standard Windows Azure outgoing bandwidth prices, which are pretty low. And then there are 2 SLA components which you need if you want to make sure that you encode and deliver your content in a supportable way. So there is this reserved encoding unit, which costs $99 a month, which guarantees that whenever you create a new encoding job, it's going to execute right away on your reserved encoding unit. If you don't have reserved encoding units, then you're part of a shared global work queue, and your encoding job might be delayed, usually by a few minutes, but theoretically by a few hours. The other reserved component you can purchase is an on-demand streaming unit, which guarantees 200 megabits per second of streaming access. So when your clients hit the media endpoints, the smooth streaming endpoints, this on-demand streaming unit guarantees that you can support 200 megabits per second, and you can purchase as many of these as you'd like. And then if you have these reserved components, you get the standard Windows Azure SLA, the 99.9 availability guarantee in all the various Windows Azure regions. So that's the way pricing works. From experience, this is not super cheap. So if you're the first case I've mentioned, you have just a bunch of training videos that you want to make accessible to your several hundred employees, this is all going to wind up to maybe a couple $100. But if you have terabytes of content, like YouTube, and you want to make that accessible to millions of customers, then this bill adds up pretty quickly, and so you definitely want to negotiate something with Microsoft. But this is not my job. I don't work for Microsoft, so I'll just leave that to you. So let's take a look at the portal, the Windows Azure Media Services portal, which is the end user experience, the administrator experience with your media services. So this is the Windows Azure portal. I hope you've already seen one of those. And there is this media services section in the portal. It used to be preview only, but it's been generally available for a few months now, so you always will have this media services component. And then here, I have this one media service, which is active. Then if I enter this media service, I have this dashboard saying your media service has been created. And down here, I have a couple of starter code samples. So I choose a language, and then, for example, if I want to upload a video programmatically, it gives me a code snippet that I can just copy back to my Visual Studio project and upload a file from my local machine. Or maybe if I want to do this in Java, and I don't want to upload a video, I want to encode a video programmatically. Again, this just gives me a bunch of Java code that I can copy-paste to Eclipse and have an issue an encoding task to Windows Azure Media Services. So this is the Getting Started tab. Then you have the Content tab, which has the various assets you've uploaded to Windows Azure Media Services. And so each asset here is a row in this table. It has a name, last modified date, size, and publish URL, which is where you can access it. So for instance, I have this, let me just see, oh, here. I have this asset here called upload test 2, which I uploaded in April. And if I go to the publish URL, there is this URL right here. I can copy this thing and simply paste it to my browser's address bar. And then here it is. This is progressive download. So the browser is just playing an MP4 file that it found online. This is a super short file. And then down here, I also have this same asset encoded to Silverlight smooth streaming, to IIS smooth streaming. And the URL here is completely different. This is quoting an origin server, which is one of the origin servers provided by Windows Azure Media Services. This is a server that can play back smooth streaming content. And so this URL I can't just copy to my address bar, but there is a built-in Silverlight player in the portal which will show you the general experience. So you see I'm on Mac here in Chrome, and I'm just going to hit play down here, and it opens a Silverlight media player which plays back my smooth streaming content. So it does work on Mac. And this works, again, it works in Chrome with Silverlight. It also works in Safari with Silverlight. And then the final example here is this HLS asset, which is the same upload test to video encoded to Apple smooth streaming. And again, there is a URL here, but Chrome is not going to be able, even on Mac, to play back this file, this URL natively. However, Safari can. So if I just open Safari and paste that URL to the address bar, then here we have the same thing playing in Safari. So Safari natively supports on iOS, on OS X, on Mac, the Apple smooth streaming format. So that's just a couple of examples of the things you can do with your assets. But let's upload a new asset. So there's this upload button here. And I'm just going to pick a file from my local storage. And I'm going to name it VS Live Upload Portal. And I'm going to hit this OK button. OK, so now it's uploading. Hopefully, it's going to be quick. And yeah, I think it's already uploaded. We're just waiting for the portal to refresh. Please refresh. OK, so here it is. This is the MP4 file, which I've just uploaded to the portal. It's not even published yet. So if I go to the publish URL, you see it says not published. So it's not by default accessible to everyone on the internet who has a link. I can publish this MP4 file, but instead let's encode it first to some smooth streaming formats. So there is this encode button on the bottom. And here I have this preset chooser where I can say how exactly I want this content delivered. So it says here playback via HTML5. This is basically going to be just an MP4 file. So it's going to take my MP4 file and encode it to another MP4 file. This is not particularly interesting. However, I have this preset here, playback on PC or Mac via Flash or Silverlight. So this is going to create the IIS smooth streaming format. Or I have playback on iOS devices and PC or Mac. And this is going to do both Apple smooth streaming and IIS smooth streaming. So let's go with this and call this thing whatever. OK, so now I can go to my Jobs tab and see my encoding jobs that are currently in progress. So as you can see here, I have 2 encoding tasks as part of my encoding job. The first task will convert that MP4 file to the IIS smooth streaming format. And the second task is going to take the IIS smooth streaming format and sort of package it to the Apple smooth streaming format. They're pretty similar. It's just a matter of some supporting files that declare the bit rates which you have in each smooth streaming format. So this is encoding. I haven't paid the $200 a month for a reserved encoding unit, so this might take a while. And we can go back to this a bit later. But essentially, I've already performed this kind of encoding job for some of the content you've previously seen. You see it's now 1% through. Anyway, going back to the content, just to show you a slightly different example. So this is Okay, so this is another example. This is a file, the Awakened Trailer MP4 file. And then again, I have the two output formats, the Silverlight smooth streaming and the HLS smooth streaming. And let's just take this thing and play it. So this is playing through the Silverlight player. This is a slightly bigger file, and it's about 50 megs, and so now it's playing. And there's even sound if you can hear it. Great. Okay, so the jobs are still here and running. I don't believe they're, oh, okay. The encoding task to IIS smooth streaming is already done. Now we're just waiting for the HLS support packaging task, so we can get back to this later. So this is the portal experience, and it works for just testing a couple of files. It even works if you have only several dozen videos that you want to upload, encode, and publish, but it doesn't quite work if you need hundreds of videos, if you want to change the output encodings occasionally. So of course there is an API that we're going to be using. So there's a bunch of steps here, and I'm not going to bore you with all the steps, just give you a general outline of what we're going to do, and then show you a simple console application which handles all of the steps I've previously done in the portal. It uploads a media file to the Azure Media Services storage. It encodes it to the two smooth streaming formats. It publishes the resulting URLs and prints them out to the console so you can then embed them in your favorite browser or delivery system. So basically the moving parts here are as follows. The SDK has this concept of a cloud media context, which is like the manager of all Windows Azure Media Services related tasks. And then that cloud media context gives you an API for creating an asset. This is the iAsset interface. An asset is just a row in that content table. And then in that asset, you upload an asset file, which is, for instance, an MP4 file. And then if you want to publish that MP4 file already, without encoding it first, you have to create what's called an access policy and SAS locator, which are actually terms, concepts from Windows Azure Storage. But these eventually wind up to a URL, a really, really long URL with a token. And you can specify an expiration policy for this token. So you could say, I want to publish this file just for 1 hour from now. And then the token automatically expires, and no one's going to be able to use that URL from, in 1 hour from now. If you want to encode, you need another thing called a media processor, which is represented by the iMedia processor interface. And the iMedia processor can encode and package your content to other formats. And so you create an encoding job, an iJob, and a job is a collection of tasks, as you've seen in the portal. So I could have a task that encodes to IIS smooth streaming, and another task that encodes to HLS smooth streaming. So these are the iTasks that you put in the iJob. And then you monitor the job progress until it completes. It has events that report progress information and errors, of course, if any. And then finally, the job has an output asset, which is what you can publish. And so again, you have to create an access policy and locator, and then you can generate URLs for the smooth streaming content you have just created. And then finally, there's a step I haven't mentioned yet, which is CDN, Content Delivery Network. And the reason I haven't mentioned it is that currently the CDN story is kind of shady. Microsoft used to have a very decent CDN offering for static assets, for files. So if you want to offer CDN around your MP4 progressive download content, that's fine, and it still sort of works. But CDN for the smooth streaming assets is more difficult because it's not just a static file. It's a bunch of files and a protocol that the server has to support. So Microsoft used to have a CDN for Windows Azure Media Services, which you had to request access to and wait like 4 weeks to get an access key. I think at this time there is no supported way to get CDN for smooth streaming assets, and it's coming really, really soon, I think, along with live streaming. So currently the story around CDN is not very good. You have CDN for static assets, for MP4 files. You don't have CDN for the smooth streaming content. So again, if your users are all in the States or maybe one part of the States, that might be fine. if you want users from Australia to quickly access smooth streaming assets located in a data center in West US, then you might need CDN, and this is something that we currently don't have in Windows Azure Media Services. So let's take a look at all of these tasks in a simple console application. So let me first give you a demo of this application. This is, of course, something that's going to be available after the session. It's called simple upload and code deliver.exe. It's a console application that takes an MP4 file and an asset name in Windows Azure Media Services, and it takes care of uploading and coding and publishing the URLs to your content. So let me just run this thing with one of my sample MP4 files, and I'm going to call this console upload vs live. Okay, so it's connecting to Windows Azure Media Services, and it's uploading the file. It's going to take a while. Let's go back to the portal to see if we can already see the asset in the content table. Okay, so the asset is here. The MP4 file was already uploaded. So at this point, we're waiting for the encoding job to start. And again, I don't have a reserved encoding unit, so this might take a little time, but it is supposed to, at some point, print out the encoding job has been created, and we're waiting for that encoding job. It hasn't happened yet. Oh, there it is. So encoding, state processing, and this is the time of the last update. Now, I don't have, in this console application, support for receiving the progress events from the job, but it's possible to receive progress events so you know if there's been any error, and also the percentage of the job that's already done. And when this completes, we're going to have 2 streaming URLs in our console. So let's take a look at the code in the meantime. So these are the basic steps here. The first thing we do is upload an asset. So we have the local file that we want to upload, and the APIs here are pretty simple. There's the cloud media context, which is, again, sort of the manager for all media services related tasks. I create an asset, I create an asset file, and I tell the asset file to upload from a local file on my disk. So this is a pretty simple SDK. When this completes, this is a synchronous call. There's also an async SDK method, but this is synchronous, waits until the upload completes. Then we want to specify the encoding parameters. So the first thing I do here is locate the asset that has the asset ID which I've just uploaded. And then I create an encoding job. This is the iJob thing. And I also need a media processor, iMedia processor, which can encode to different formats. And once we have that job and that media processor, I can create an encoding task. And I have 2 tasks here. The first task encodes the MP4 file to IIS smooth streaming, and the second task takes the output of the first tasks and encodes it to Apple smooth streaming. And then the job's output is the result of the output of that second task. So it's all just chaining tasks and jobs. I have the first task that has an input asset and an output asset. And then I have another task whose input asset is the output of the first task. And the output asset of that second task is going to be the output of the whole thing. And then I say job.submit, wait for the whole thing to complete. And then I have these helper methods here which generate the streaming URLs. These are URLs you can put in your browser, you can put in your video element, you can put in your in-app video playback screen. And so the code for print streaming URL for asset is kind of long. It's kind of boilerplate code that accesses the Windows Azure Storage APIs to create this access policy and locator. One interesting thing here is that I specify the streaming URL to be valid for 365 days. And I also specify that what people can do with that streaming URL is just read and list the asset. The read is obvious, the list is also necessary. But hypothetically, you could also create this kind of URL with write permissions. So people could write to your asset, and that's not part of what we want here. And that's the reason we need this is that we're using the storage concepts for URLs. And so at the end, this thing just prints out to the console the streaming URLs that have been created. So if we go back here, it's just about done. And we have two streaming URLs here. And they're almost the same, except this GUID part right here. And except at the end, here I have .ism/manifest. And here I have .ism/manifest format M3U8 AAPL. So the second one is the Apple HLS format URL. The first one is IIS smooth streaming. So I could take this URL and paste it into Safari, or I could take this URL and paste it to a Silverlight-based player, and we have them ready. So this is how you can encode assets en masse. You could have a folder with several terabytes of input files and just run this sort of console app on all these files till they're uploaded and available. But again, the management experience around these assets and files is just this content tab in the portal. And you can imagine that if you have several hundred or thousand files in here, it won't make sense to manage these assets, publish, unpublish them from here. So there are several custom third-party content management solutions around Windows Azure Media Services because the portal is clearly not sufficient for serious media content. There's nothing I can show you right now. These are all third-party offerings. It's still unclear exactly what's going to be the best thing to use. If you just want some references, I can definitely provide you with some, but the current in-portal experience is good for testing and development, but you will need some additional layer for your webmasters and administrators to see exactly what you have uploaded, if there have been any errors, if the URLs are expiring, and so on. And I have a sample of this, which I've written, but it's not anything you can really use in a production application, which basically looks like this. So it's a simple table hosted in a Windows Azure website that has your assets, and it can track the status of the job. So when you upload a new asset, it's going to say, OK, I'm now encoding it. When the encoding is done, it's going to say ready. If there's been an error, it's going to say there's been an error. And I have a bunch of links here to the different output formats. So I have MP4 source, which is progressive download, and I have links to the different smooth streaming formats. And I also have an auto-detect link here, which will try to guess based on your user agent string which delivery method is going to be appropriate. So if I click auto-detect here, it's going to open a Silverlight player. Or at least it's supposed to open a Silverlight player. Oh no, this is actually not a Silverlight player. This is the MP4 progressive download player. But if I take the same thing and paste it to Safari on iOS, let me zoom in a bit. Paste. No, not this. Sorry. WAMS SDP 13. OK. Paste. No. OK, let's type this out. OK, so here's this table in the Safari iOS simulator. And if I click auto-detect here, then it's supposed to open the, yeah, there it is. This is the Apple HLS player. OK. I have no idea what these MP4 files are. I just looked up online for freely available MP4s and shoved them into my media service. Anyway, so you definitely need this kind of management system on top of Azure Media Services for real content, for real encoding needs. And I'm going to describe the process I went through here in a couple of minutes. But first, just about the playback experience, I want to just kind of clarify how easy it is to play back the different formats that we have seen. So MP4 files, to play back MP4 files in any modern browser, pretty much every browser you have that's been released in the last 10 years, you simply use the video element, the HTML5 video element in any page and point that to an MP4 file. And this is essentially what I do here. So if we go to the MP4 source link and I click View Source, So this is the source. I simply have a video element with the width and height, and the source is pointing to that huge, long Windows Azure URL. You can see the token, and there's also the expiration date and signature for that media asset in Windows Azure Media Services. But this is essentially an MP4 file. This is nothing more. For other output formats, you need something a bit more complex. So for instance, to play back IIS smooth streaming, you have the Silverlight plugin to help. And Silverlight, again, is supported on Mac in browsers and on Windows in different browsers. And there is a sample player, a sample Silverlight player that you can use, available here on CodePlex. It's a Microsoft project, but it's not officially supported. It's called Player Framework, and it's basically a precompiled ZAP file, a precompiled Silverlight application that you can simply put on your web server or in Windows Azure websites or any other hosting solution that you use. It just has to support Silverlight. And then your browser simply uses that ZAP file. So on the client, you have the Silverlight host object, which uses that ZAP smooth streaming player. And the player simply has an input parameter specifying the media URL. So you can add this to your website in maybe 10 lines of code, plus that ZAP file that you have to put on the server and make it accessible to the browser. In fact, you could even host that ZAP file somewhere else, not necessarily on your own server, but this is what we have in this example here. So again, this is really, really easy. And for Apple HLS, again, the same approach with the video element would work on iOS and on OS X in Safari. But also another thing I wanted to show you is that it's also supported in-app on iOS, and it's also supported in-app on Android. So on iOS, you simply have this API called MP Movie Player Controller, which can play back HLS files, HLS URLs. You give it the HLS URL, and it starts up this nice full-screen media player. On Android, there's a very similar thing called Video View, which you give a smooth streaming URL, and it's going to play that back, even though Android only supports the HLS format officially since Android 3.0. But it also works on some select Android 2.0 devices. The story there is less clear. So let me just show you a quick example of this. I have here an Xcode, an iOS application that uses this MP Movie Player Controller API. And this application basically looks the following. It takes a URL, and it has a play video button that will play that URL. So let me just grab this Apple Smooth Streaming URL from here. It's going to be kind of hard to copy this. Okay. Let's first put this in here. Remove the prefix. Okay, so this is the URL that I can now paste into here. Oh, come on. No, I want to delete the whole thing. Select. Please let me select. Okay, select. Very well. And now paste. Okay, play video. There it is. So this is a custom iOS application that simply uses the built-in media player API to play back Apple HLS. So now I'm just showing you a bunch of unrelated examples here, but the idea really is that if you encode to both smooth streaming formats, you can find a solution to play back these files, these URLs, from virtually any device your customers might have, including, again, feature phones and older browsers which only support the video HTML element or have some custom SDK for accessing MP4 files. If it can play MP4 files, it can play your assets from media services. So I've just shown you a couple of examples of delivering assets to various devices. And so the last thing I want to show you before we get on to questions is this end-to-end experience of uploading assets to some endpoint in the cloud and producing this content management system. So the example I have, which I'm going to share with you after the talk, consists of several moving parts, all hosted in Windows Azure. So the only part that you have to do on premises is upload a file, an MP4 file, to some Windows Azure endpoint, and it takes care of encoding, monitoring the encoding job, recording any errors, and producing this little HTML table that has the status of different assets. So the process is as follows. The upload application on the client side simply uploads to an ASP.NET website hosted in Windows Azure. This is a really simple website. It's, the free tier would work perfectly for this because it virtually doesn't do anything, except it takes the file produced by the upload application and stores it in Azure Blob Storage. So it simply tunnels a file to Azure Blob Storage. From this point on, your client-side upload application is done. It doesn't know anything about Windows Azure Media Services. It simply posts actually a file to an HTTP endpoint in Windows Azure and forgets about it. And then the ASP.NET website also records in Azure Table Storage. In this case, it could also record this in a SQL database, the status of that encoding job. So it says, it stores in this table the fact that a new asset has been received and that we now have to encode and publish it. And then I also have a queue, a work queue, also part of Azure Storage, in which I put a message saying, okay, there is now a new asset that has to be encoded. On the other side of this queue is an Azure worker role, which is essentially, if you haven't seen worker roles before, it's like a Windows service that's hosted in Windows Azure. It's a simple background component that can run arbitrary code. And so the worker role pulls the message from the queue and then starts talking to the Windows Azure Media Services encoder to start encoding the file. It also uploads the table to say that this asset is currently being encoded. And then it waits for the job to complete. When the job completes, it uses the Media Services streaming endpoint to generate streaming URLs. And finally, it puts these in the table as well. So this end-to-end flow is all going to be available to you. It's just a simple Visual Studio solution with 3 or 4 projects. And this table that I've mentioned is really, really simple. This is what the table looks like. Let me just open the table for a second. This is what the table looks like. It has the asset name, timestamp, HLS streaming URL, MP4 URL, Silverlight URL, job details, and status. So it's essentially what you have seen in the HTML page. So this is the backing storage for that HTML page. And then the overall flow is as follows. So this is the portal, so to speak, that has the 4 assets I currently have. And I'm going to upload a new one. But again, I'm not uploading to Windows Azure Media Services directly. I'm only uploading to an HTTP endpoint hosted in Windows Azure that's going to take care of the whole end-to-end flow. And to illustrate this, I'm going to use curl. So I'm going to post using curl to the website, to the ASP.NET website's HTTP endpoint, a particular file that I have offline. And as soon as that post completes, as soon as the file has been uploaded, there's nothing else that I really need to do. So let's just wait for this upload to complete. There it is, uploaded successfully. If I now refresh the table, you'll notice there is another asset here, upload test 4, which is currently in the encoding state. Now, the MP4 source is already available for playback. I can already play the MP4 file because I've just uploaded that MP4 file, but I can't yet play the streaming formats because the encoding job hasn't completed yet. And now I can refresh that portal and see the encoding task information with the progress information as well. I'm not actually uploading this progress information live, so it's always going to show as 0% until it's done or until there has been an error. But from a webmaster's perspective, this is much easier than using the portal. They only have to post an HTTP an MP4 file to an HTTP endpoint, or they could have some sort of FTP solution that puts the file on an FTP server, and then a totally hosted cloud set of services picks up the file, puts it through the whole encoding process, and generates this nice table. So there's a bunch of CMS, content management solutions like this. This is obviously just a simple demo. So it's going to take a while for this to complete, obviously, but eventually we're going to have the streaming format supported as well. So this is the end-to-end flow that you can put on Windows Azure. And let me just give you a quick look at some of these components. For instance, let's take a look at the website part and the worker role that communicate through a queue and this table. So the website is right here. You can see the table components here. And here is the controller that drives this experience, the home controller, obviously. And I have a couple of helpers that make it really trivial to implement this controller. I have this method here, asset manager get all, which returns objects of type media asset. This is my custom model, and it has inside all the URLs and the status information for that job. The interesting part, I think, is the upload. And so here I have an HTTP post method on my controller that takes a file and uploads that file to Windows Azure Blob Storage. And again, there's some Windows Azure storage specific APIs in here. The Cloud Blob client lets me upload the file directly to Windows Azure Blob Storage. And after that, you see familiar concepts like iAsset and iAsset file. And so in this case, the news is that I'm uploading a file to Windows Azure and storing it in blob storage, and only then I'm telling media services about that file. So the client never sees my Windows Azure Media Service. The client only sees this HTTP endpoint. I put the file in local storage and then tell media services about it. So this also protects, in a way, my media service from the clients, more secure. And then eventually, I put a message in a cloud queue. So this is the related code. Cloud queue client, cloud queue, create if not exists, and then I just put a message in that queue with the ID of the asset that I've just created in media services. And on the other side of this queue, just to remind you of the diagram, on the other side of this queue is a worker role that runs in Windows Azure. And that worker role is really simple. This is what the worker role does. It runs in an infinite loop and runs this method encoder run loop, which is right here. And in encoder run loop, I simply pull messages from the queue, pull messages from the work queue, and when I receive a message, I delete the message from the queue, and then I start the whole encoding pipeline that you've already seen in the console application. I create a job, I create the tasks, I wait for them to complete, and so on. So this guarantees that even if the website goes down, I still have that message in the queue, and the worker role is eventually going to process that message. And if the worker role goes down, I can also use transactional queue semantics so that if the worker role goes down before committing that queue transaction, the message would reappear in the queue. So I never lose information about a job. So this is kind of the end-to-end flow that's now possible. Okay, so this is almost it, and I'd really like to hear if you have any questions. Let me just summarize. Azure Media Services, as you have seen, lets you upload and code and deliver your media assets through a variety of formats. We have progressive download on one end, and we have two smooth streaming formats, which make it accessible to virtually every device, every smart device and browser out there. We have the .NET Management SDK, which we have seen. There's also a Java client, if you prefer Java. And there's REST HTTP endpoints, if you prefer to use with media services from some unsupported language and framework. And finally, Windows Azure Media Services, like anything else, is available as part of the Windows Azure free trial. And recently Microsoft has made that trial even more compelling because it doesn't require a credit card to sign up. You can just start using it right away. And if you're an MSDN subscriber, you get monthly credits to use Windows Azure for free. So for instance, if you have MSDN Premium, you get $100 a month that you can use for anything on Windows Azure. If you have MSDN Ultimate, I think it's $150 a month. And it's more than enough to encode a few gigabytes of files, to package them into different formats, to see if the reserved units work for you. It's definitely something that you can do with your MSDN subscription benefits as well.